this splitting may be further explained very nicely in terms of our familiar projection idea. So here you have this column space of X, and here you have the data vector. Now what you are doing here is that I am splitting it up into lots of orthogonal components. So I am splitting it as expressing this y vector as sum of 1, 2, 3, 4 and 5 different parts, each of which are mutually orthogonal. Now, of course, I cannot reasonably show this because I am giving an example in R3. I cannot come up with 5 mutually orthogonal directions in R3. So you have to take this picture with a pinch of salt, but you understand what I mean. And each of these directions are actually components of the y vector along this direction. So let's understand carefully. This is my y vector, and I am projecting it along the direction of the intercept, that is along the direction of 1, 1, 1, 1 vector, and I get a component that is my this thing. Now, after I have removed this, I project the remainder onto the remainder of the red part, and I get another component which I am showing it as the red arrow. So the red arrow is perpendicular with this gray arrow. Then again I am looking at the remaining part and I am projecting it onto the purple thing, and that gives me the purple arrow. Of course, after removing the effect of the intercept. Similarly for the blue thing. This part completely explains the projection of my y vector onto the column space of X. Whatever remains, that is orthogonal to all these things, and that is the black part. That is the residual sum of square. In that case, by a generalized form of Pythagoras theorem, I can say that the norm square of this is actually sum of norm square of all these components, and that is indeed the sum that we are looking for. So those norm squares of each of the components are playing the role of the different component sum of squares, and they are also adding up. So early statisticians figured out that this is the condition that you need if we want to split up the total sum of square in terms of component sum of square. So they came up with a necessary and sufficient condition for which you can do this, and unfortunately they also found that this is not always possible.